So thanks for hi to those of you who have come back for this little discussion. Um, Many of you, of course, are sort of most interested in the work of your specific advisor and the kind of specific plans um, that you hope to pursue while you're here. But sometimes it can have a bit of a kind of instructive uh, experience to understand the unique kind of character that kind of each institution has. Different places have their own sort of style and focus and way of working, and these are things that are in common to sort of lots of the research that happens at Rutgers. So I wanted to do what I could in a short period of time to talk about the identity of the Rutgers CS department, the kind of themes, highlights, and accomplishments that characterize work here over the 55 years that we've had a computer science department. And that will help us to frame sort of some of the unique ways that research happens in the department through a range of centers and training programs that help to enable students to achieve the kind of distinctive kinds of research excellence that Rutgers is particularly strong at. Um, so I want to thank uh, my colleague Kaz Kulikowski for these slides that I'm using. So Rutgers, it, you'll dig into the history. It's a colonial college and won the land grant competition for the state of New Jersey. And then with the GI Bill after World War II, really boomed as a um, large state university. And the founding of the CS department by Fred Fender more than 50 years ago sort of catalyzed the computer science research at Rutgers in the context of this new energy that the university was having at the time. Um, in many ways, the most the research side of things got its sort of distinctive character through the efforts of Saul Amaral, who was the first chair of the was hired outside as chair of the department from 1969. What actually happened was that the computer theory group at the Sarnoff Research Center, which is now NEC Labs, sort of decided to, in some sense, move to academia. And so a whole cluster of faculty were hired and established a CS master's and PhD programs at Rutgers in the late 1960s. Saul Amaral was famous for work in AI on problem representation. So he was one of the first people to characterize the way that the formulation of a search space can have a huge impact on the ability of automated methods to find problems. And of course, that's even in today's era of sort of machine learning and game playing, the way that AlphaGo, represents its search space is kind of crucial to its success. In some sense, continuing the insights that go back to Saul's work. At Rutgers, Professor Amaral turned his focus to possible applications of artificial intelligence, and particularly in biomedicine. And there were a bunch of AI faculty hired at that time, including Professor Kulikowski, and their work on sort of applying AI methods in disease diagnosis, prognosis, and treatment was one of the first and influential experiments in sort of expert systems broadly and computer biomedicine applications in particular. They sort of continued with their this kind of model-based approach throughout the 1970s and beyond. There's a sort of key lesson from that work that continues to play out to this day, which is that successful research in these kinds of applications really requires the joint efforts of computer scientists and domain scientists, in this case, like medical experts. There was always a close connection between the computer science efforts in this area and doctors and medical researchers to make sure that the sort of knowledge and models and inference mechanisms that people were developing really responded to the medical science and the needs of professionals. And so, that's reflected in the fact that these early efforts had meaningful impacts on patient health, for example, in treating, in this case, infectious eye diseases in Egypt. So it's always, people might wonder why talk about stuff that happened so long ago, but actually the intellectual community that Rutgers offers really is continuous. I joined the faculty while Saul Amaral was still here, and he and I had sort of meaningful conversations about research that influenced me. And in general, sort of all of the names that you'll see on these slides, even if they're faculty or not still at Rutgers, created an intellectual landscape in the department and at the university that persists, thanks to the ways that they put ideas together, created courses and training programs, and sort of educated the community here about the relationships between ideas and the kind of possibilities for research. And those kinds of connections, once they're made, are lasting and inform, what it's like even today for PhD students working in the department. And this theme of looking at computer science in connection with its applications and working in collaboration with domain experts across fields to make research contributions that bring CS forward, but also make advances in those other fields, is one of the kind of signature features of computer science at Rutgers, something that our department has always been doing. And that is increasingly recognized as sort of how computer science gets its impact and how computer science moves forward as a field. So in the sort of subsequent history of the department, you can see new kinds of cross-disciplinary collaborations forming and becoming institutionalized, and sort of stronger and stronger connections being made between the practice of computer science and the research in computer science itself, and the many fields of science, engineering, and beyond that draw on computer science to make progress. So after this early connections between, say, AI and medicine, throughout the 1980s and 90s, Rutgers continued to pioneer and lead new kinds of interdisciplinary connections that sort of enrich and broaden computer science. And some of them are highlighted on this slide. There's the connections between mathematics and theoretical computer science that are typified by the work of our colleague Andre Samaretti, whose work in combinatorics revealed sort of fundamental facts about number theory and mathematics. At the same time, as you saw during the pitch talks today, they enabled fundamental practical algorithms and things like hash tables. This kinds of connections were institutionalized by the launch of the Dynex Center, which I'll be talking about a little bit more, which continues to provide a kind of thriving environment for theoretical computer science in its relationship to a wide range of other fields. A different kind of cross-cutting connection represents the involvement of computer science in mobile computing, where new advances in networking and devices, spearheaded by our colleagues in the electrical and computer engineering department, were coupled with changes in operating systems, databases, and other sort of application level and user-facing technology to kind of lay the groundwork for the computing infrastructure that we take for granted today with smartphones and connected devices. So Rutgers institutionalized these kinds of connections again through the WinLab Center on Wireless Information and Networking, where many of our faculty have relationships. And it again continues to be a thriving leader for these kinds of research problems. But, as an example, Professor Imolinsky and Professor Nath did some groundbreaking work in the framework of these kinds of ideas to understand how users would get information in sort of mobile devices, taking into account the kind of spatial constraints associated with queries. Around the same time, Rutgers really got on the map in cognitive science, which explores connections between computer science and AI with psychology and philosophy. Again, this is typified by the work of the triple AI fellow Zenon Palishin, who Rutgers recruited to launch the Cognitive Science Center in 1994. So these periods saw a large amount of growth in the department, including a whole number of very distinguished people, again, whose ideas sort of continue to shape the way computer science is viewed and within the university and the way it's taught in the department. This is a sort of snapshot of a CS theory at Rutgers from 30 years ago, where we have Diane Souvain, Andre Samaretti, Mike Fredman, Leo Kachian, Vashek Schwassel, Bahman Kalantari, Anya Sahari, and Phil Steiger. And, I guess with the end of the semester, the last of these people that's on the faculty, Bill Steiger, will be retiring. And so this is sort of, for me, I'm showing them as my friends, but For you can think of them as the kind of um, ancestor figures, if you like, that uh, really showed that mathematical and algorithmic techniques were closely tied together and could have a lot of influence on um, a wide range of practical problems. Um, we've continued since then to sort of regularly hire prestigious senior scientists, um, you know, to pursue the same kinds of outward-looking research. So our work in the department on the links between AI and medicine uh, got a much uh, um, got a new twist, let's say, by hiring Dimitri Metaxas, who added a lot of uh, computer vision and simulation into the repertoire of kind of diagnostic and clinical research that we could do here. And the CBIM Center that he leads institutionalizes those kinds of connections. In theoretical computer science, sort of Mario Segedi brought connections to quantum computing. Rebecca Wright brought connections to privacy and security. And Mutu brought connections to electronic commerce and internet scale algorithms. And the Cicada Center institutionalized some of those connections in relationships between theoretical computer science and homeland security applications. In cognitive science, people started looking more at learning and perception, where the computational architecture of memory and decision making proved to be sort of a particularly exciting point of contact between emerging research trends in psychology, neuroscience, and computer science. And sort of the past couple decades saw this institutionalization of a perceptual science graduate training program that explicitly introduces people to both the kind of computational models of human perception and AI models of machine perception in correspondence with one another. Since 2015, we've continued to hire, essentially as fast as we can. So this is the list of the faculty members that we've hired since 2015, all of whom are still, for the moment, assistant professors, meaning that they're still bringing a lot of energy and creativity to their research program, and still are kind of defining the research that they aim to be doing going forward. And these researchers span sort of computer graphics, machine learning, algorithms, databases, robotics, operating systems, and data mining, smart cities, and more. So in addition to this intellectual continuity, it's this kind of very exciting moment where this kind of snowball that we got rolling so long ago has really sort of ramified and gained momentum to impact really all of science and all of engineering and sort of all of human life. So that's a kind of where we've been and how we got to where we are, and how that sort of created an intellectual and institutional context for the kinds of research that we really like to do at Rutgers. I'll take a few minutes to just give a snapshot of how those institutional structures are working now by giving some highlights of the activities of the centers that we have and the training programs that are underway, to just underscore how it is that we hope to get sort of our students and the whole community on board with meaningful collaborative work that combines computer science with the domains in which computing has an influence today. So the three centers that I'm going to talk about are CBIM, CDDA, the Center for Dynamic Data Analytics, and DIMAX. So CBIM, as I suggested, sort of continues to look at computer vision, medical applications, and then the broader context in which that works and problems like AI and object recognition or understanding human behavior. So an illustration of sort of how computer vision plays a role in tandem with medical science is in Dmitry Metaxas's work on modeling the movement of the human heart. His colleagues in radiology use specially instrumented magnetic resonance imagery to be able to take snapshots of the heart with tags that show how the tissue moves over time. And what's then necessary is to organize the imagery so that you can recognize the anatomical structures, but also put them in correspondence with one another to kind of track the motion that's implicitly visualized in these successive MRI images. And what you can then do is build much more realistic simulations of blood flow and heart function as a diagnostic tool, but also as just a scientific understanding of the behavior of healthy and diseased hearts. And these studies have revealed kind of qualitative features of the heart in motion that were not known before, because they're only only take place when the heart is sort of completely surrounded by tissue. And so when you try to and it depends on the exact kind of, the movement depends on correspondences that you can't just see from successive frames of imagery. A new project that Professor Metaxas has just launched in collaboration with Maria Paula D'Imperio from the linguistics department is a NSF convergence accelerator to understand computationally and scientifically the structure of American Sign Language, which is a sort of an illustration of the continued sort of promise and energy of these kind of ways of using computer vision technology to get scientific and socially impactful results in analyzing people. So the Center for Dynamic Data Analytics is a joint effort of Rutgers and Stony Brook, which is a regional innovation hub enabling connections between academia and industry in areas that require sort of data science generally, but particularly things related to machine learning and analytics. So it has a range of companies involved, as well as academic researchers, and it provides a framework for companies to sort of share their R&D challenges with university researchers to frame meaningful problems for students to work on, as well as enabling students and other researchers to find pathways to transition new technologies into actual products. And these kinds of connections between university and industry, again, are the kind of collaboration that's necessary to make sort of technological advances sort of not just sort of neat demos that you see and then sort of put on the shelf and move on to the next thing, but things that really become part of everyday life, the way the mobile technology that was developed at Rutgers has done. The last center that I wanted to talk about is DIMACS, which a math and computing research center that again draws in academic and corporate partners together to really spark new kinds of research relationships, conduct the research, and prepare the next generation of students to be able to participate in these kinds of cross-cutting events. The signature activity in DIMACS is a special focus year designed to catalyze research, something that requires expertise from mathematics or computer science or more is poised for advances and benefits society. The typical activities of a special focus is workshops, tutorials, working groups, seminars, and visitors, so that there's a kind of energy based at Rutgers to kind of create a community and define the problems that are going to motivate and sustain a new research area, while making sure that both established scientists and sort of new people joining the field are able to participate through educational efforts. And so that currently the things that DIMACS is working on is bridging continuous and discrete optimization, lower bounds in computational complexity, and mechanisms and algorithms to augment human decision making. So these are the kinds, so you can see that when you need to do these interdisciplinary and sort of high impact projects in computing, because it's a collaboration that involves people outside computing, there's a kind of need to institutionalize those collaborative relationships, which in a lot of cases happens through centers. And you see that there's a wide variety of activities that sort of characterize those collaborations, from sort of collecting and analyzing data, sort of evaluating prototype systems in context, to building relationships among researchers, creating new communities, and connecting academia to industry and the other parts of society that's going to deploy the research. Sort of being in a dynamic computer science department means sort of providing these kinds of institutions to bring people into collaborations, prepare people for the collaborations, and then sustain those collaborations, not just to the point that they get research accomplishments and high impact publications, but to the point that they get meaningful uptake of their ideas, not just in computer science, but in academia generally, and then in society. And training, I guess, is just as important as research in sort of sustaining these kinds of collaborations, because in some sense, you can't just sort of jump in uh, to one of these networks. You need to understand what computer science brings and how to build bridges between computer science and other areas. And we offer training programs in the department at all levels to um, enable students to participate meaningfully in these kinds of projects. You know, it starts with undergraduates. DIMAX runs an extremely prestigious REU program with about 35 undergraduates coming from all over the country and internationally. Um, um, uh, we also offer at the undergraduate level a living learning community for undergraduate women that connects women not just with sort of peer group in computer science, but with the broader Douglas Residential College, the Women's Residential College at Rutgers, their efforts to create networks to train women in women's leadership and allow women to understand not just the kind of technical work that they're doing in science and technology, but also sort of the social needs and opportunities that they're sort of uniquely positioned to address in virtue of their shared experiences. We offer support undergraduates with this cave space, you know, where again collaboration is the kind of key theme that we're trying to foster with the space, where it's kind of a startup vibe, where whiteboards, computers, and shared space make it possible for people to explore ideas in team settings and not just sort of as a one-on-one classroom environment. And the students themselves do an enormous amount of work. They've really taken up this kind of collaborative vision for what high impact computer science is and lead the way in a whole bunch of activities. So Rutgers computer science undergraduates run one of the largest hackathons on the East Coast, happening twice a year. And there's a sort of a sample of the kind of things that they do. At the graduate level, you know, a lot of what we do to support training is to create specific kinds of interdisciplinary course sequences and experiences that sort of provide a kind of structured introduction to specific kinds of interdisciplinary research. And these are formalized at the graduate level by certificates that recognize that if you take a handful of courses, it often prepares you in a unique way to participate in team research on important problems. So one that just launched this year is the Socrates program, Socially Cognizant Robotics for a Technology Enhanced Society. And the idea is to train students through a mix of computer science, engineering, and social science methods to be able to design systems where robots interact with people more effectively, taking into account sort of what we know about people and thereby ensuring that the technology, to the extent possible, provides broad benefits for people and avoids unanticipated harms when those things are deployed. And so these are the kinds of things that will be needed in order to address the kinds of future challenges you see on the slide. Having people work in the same workspace with robots, making robots that are truly collaborative for ordinary people, and allow for sort of meaningful control and participation in how those robots work by not just technologists, but the people that are most concerned with what the robots do and need those robots' help. And that's just a sort of one example. We also have a range of other certificate programs reflecting other kinds of interdisciplinary collaborations, as well as lots of seminars, courses, and other things that enable students to get the background across disciplines to connect things in new ways. Some of the exciting things happening in the department right now in this area include quantum computing and information systems, connections between machine learning and human learning, and of course our sort of training programs that highlight the opportunities for big data and analytics and concrete problems in industry and then across sciences. So this is the end of the talk. And so I'll just kind of close with that and just hope that that gives a sort of useful feeling for some of the things that the way that Rutgers really promotes the kind of research that we think is the most meaningful and the kind of research where over the years our department has had the most success and the most impact. So you can think of it as this was a really intentional process to promote the kind of vision that we see for computer science and that we'd like you to get involved with. We'd like you to get involved with it here, in fact.